Question number 11 says the seniors are hosting a talent show. Tickets in advance cost $5 and tickets at the door cost $7. Here now we're going to be referring to the number of advance tickets as A, and the variable we'll use for tickets at the door is going to be D. There were 400 guests that attended the show that allowed the senior class to earn $2,300. How many guests bought tickets in advance? Oh, that's what we need to figure out. The number of tickets purchased in advance and how many bought tickets at the door. Okay, so that is our objective, this right here. So what information do we know right off the bat? Well, we know that they made $2,300 through the combination of tickets purchased in advance and tickets purchased at the door. All right, so advanced tickets, A, cost $5 each. So we can write that like 5A plus what? Tickets purchased at the door. So that's going to be 7D equals, as we just said a second ago, the amount of money that they just made, $2,300. Do we know anything else? We sure do. I see that it says that there were 400 guests. That's a lot of people. So there were 400 people there, and those people either purchased tickets how? Either in advance or at the door. So we've got these two equations, and we can figure now how much the value was of people purchasing tickets in advance or at the door. So now what we're going to want to do is determine the value of tickets purchased at the door by eliminating the variable A for advanced tickets. We're going to be doing a little bit of elimination. So we need to think about how can we eliminate A? Well, we know that the coefficient's got to be the same, but the sign has got to be different. So we're going to be multiplying this bottom equation by -5. And now I'm going to rewrite the top one real quick, and I can see that it's 5A plus 7D equals 2,300. And now let's distribute. So it's going to be -5 times A is going to give us -5A. -5 times D is going to give us -5D. And then -5 times 400 is going to give us -2,000. All right. So let's take a look. 5A minus 5A is 0. 7D minus 5D is going to give us 2D. And then 2,300 minus 2,000 is going to be simply 300. We're going to need to eliminate or isolate for D. Eliminate 2 by doing the inverse operation. 2's cancel out. So D, of course, equals 150. And that is the number of tickets sold at the door. We're not done yet. We got to figure out how many tickets were purchased in advance. So what I want to do is I'm going to use this formula right there, A plus D, advanced tickets plus door tickets equal 400, the quantity of tickets sold in total. And so what I'm going to do is A plus, instead of D, I'm going to put 150 equals 400. So now we've got to figure out how many tickets were sold in advance. Let's subtract 150 from both sides. And I know that that means that A equals 400 minus 150, 250. So the number of tickets purchased in advance, 250. The number of tickets purchased at the door, 150. Question number 12 says, Ezra and Amir, astronauts on Mars, were playing catch with a Martian rock. The rock's position, which is in meters above the ground versus time in seconds, was mapped out in this chart below. So let's take a look at this chart. So here we've got time, and we've got position and meters. It says, find the average speed of the rock between 0 and 3.5 seconds. So here is 0, and let's see. Here is, of course, meters. Here is the position. The first thing that I'm going to do is I'm going to label the variables. So time is always our domain, and we're going to refer to it as the x variable. Position is going to be y. And this question, it says find the average speed, right, or the rate, or the slope of this rock between 0 and 3.5 seconds. So where is 0? We're going to be starting right here, and actually what I'll do is I'll circle that. Great. And then where are we wrapping up? The average speed between 0 and 3.5 seconds. Okay, great. So this is going to be our x1. This is going to be our x2. This is going to be our y1, and this 6.3 is going to be our y2. Great. So we're figuring out the average speed or rate. In this case, we're going to be using the slope formula. So y2 minus y1. y2 is 6.3 minus 1 divided by 3.5 minus 0. Great. So what does that come out to? 6.3 minus 1, of course, is 5.3 divided by 3.5. And what is the slope? If you pop that into your handy-dandy calculator, you're going to figure out that the speed is 1.51, crucially, meters per second, because, again, it wants the rate. And this is our answer. Here we've got a question on sequences. If you need a little bit of a refresher, please go to mrdroz.com. And now for 13, it says an arithmetic sequence have terms a sub 3 equals 40 and a sub 7 equals 32. What do we need to do? The first thing is writing an explicit equation describing this arithmetic sequence, and then we've got to find the 100th term, a sub 100, right? So to write an explicit equation, we need two things. We need to know the difference, or the amount it increases or decreases by each term, and we need to know the first term. And what do we know? We know that a sub 3 equals 40, and we know that a sub 7 equals 32. So I'm going to rewrite that right now. A sub 3 equals 40, and a sub 7 equals 32. Great. So how do we figure out what the difference is? We remember that the difference is going to be the final minus the initial value, and then divided by the final minus initial term. So what is that going to look like here? It's going to be 32 minus 40 divided by 7. This is the 7th term, right? 7 minus 3. 32 minus 40 is going to be negative 8. 7 minus 3 is 4. And so the difference is negative 2. So each term, it's going to be going down by 2. We're subtracting by 2 for each term in this sequence. But we're not done yet. We've got to figure out what the first term is. So let's do a little bit of quick review. Here we have the explicit equation formula for an arithmetic sequence. You guys, this is super important. Please make sure you're familiar with this. And what we're going to do now is we're going to plug in this information so we can figure out what the first term is. What we're going to do is I'm going to select, I know it says a sub 3 equals 40, right? So what we're going to do, the a sub 3 equals 40, a sub 1 equals the difference, which we just said is negative 2. And if the term that we're referring to right now is 3, we can do 3 minus 1, because it's n minus 1, right? We also know, of course, that the value of the third term is 40, right? We can't forget that. So what we're going to do is we're going to now plug this in. 40 equals a sub 1 plus negative 2. And now we can't forget that n minus 1 is 3 minus 1, and 3 minus 1, of course, is 2. Great. So let's do a little bit of algebra. We're going to carry down the 40 equals a sub 1. And negative 2 times 2 is going to be negative 4. Great. So what is the first term? We got to apply the inverse operation and add 4 to both sides. So 4 minus 4 cancels out, and a sub 1 equals 40 plus 4 is 44. Great. So we just figured out a really crucial part of this explicit equation. And now let's take a look. It says find the 100th term. So we just did a, right? We just figured out what the first value, what the first term is. Oh, and you know what? We were going to have to rewrite this as the, it says, write the explicit equation describing this arithmetic sequence. So what is the explicit equation? It's going to be a sub n equals 44 minus, or we're going to do plus negative 2 times n minus 1. All right, guys, this is the answer for part A. That is the equation. Great. But part 2, the second half, it says find a sub 100. What is the 100th term? So what we're going to do is we're going to rewrite it like a sub 100, because that's what we don't know, equals the first term, which we just figured out is 44, minus the difference, which is 2, and then multiplied by n minus 1. In this case, n is 100, so it's going to be 100 minus 1. Beautiful. So we can then figure that out like this. A sub 100 equals 44. And then what's 100 minus 1 is 99. 99 times 2 is going to be 198. Great. 44 minus 198 is going to be negative 154. And that, ladies and gentlemen, is the answer to part B. Tremendous. Question number 14 says a geometric sequence has the terms a sub 1 equals 20 and a sub 2 equals negative 10. Part A, find the common ratio, then B, write an explicit equation describing the geometric sequence. So part A, find the common ratio. What is the formula to find the common ratio? It's a sub n divided by a sub n minus 1, which means this is like a term in the sequence divided by the previous term in the sequence, the one that comes right before it. And in this case, it's actually kind of easy because we have the first term in the sequence and we've got the second term in the sequence. So to find the ratio, we're going to do the value of the second term, which is negative 10, divided by the previous term in the sequence, which is, a sub 1. The value of it is 20. So it's going to be negative 10 divided by 20, which simplifies to negative 1/2. Now we've got to write this as the explicit equation describing this geometric sequence. What does that look like? It's going to be a sub n equals the first term. And what is the first term? Oh, it's 20. We know that because it says a sub 1 equals 20. So it's 20 times the ratio, which is negative 1/2, raised to n minus 1. This is the answer to part B. And here's the answer to, here's the answer to part A. Here's the ratio. Number 15 says, using the recursive equation, find the first 5 terms. All right, on closer inspection, I see that here we've got sort of like our template, right? This is the operation we're going to be using to transition from one term to the next. And we've also got our first term in this recursive equation, which is a sub 1 equals 3. So we've got to find the first 5 terms. So what I'm going to do is I'm going to write this like this. A sub 1 equals 3. Easy, right? We've also got to figure out a sub 2, a sub 3, a sub 4, and a sub 5. And what is the sequence? What is this template that we're going to be using? We're going to be adding 2 each time. So 2 to the previous number or the value in the previous equation. So I'm going to set it up like this, and you'll see why in just a moment in case you need a little bit of a refresher. All right, so a sub 1 equals 3. All right, that makes sense, right? So in here, in this area, we're going to be putting the value of the previous term. In this case, it's 3. So the value of a sub 2, 2 plus 3 equals 5. Great. So now what we're going to do is we're going to be taking 5 and we're going to be putting the value of the second term right here. So a sub 3 equals 2 plus 5, which is going to give us 7. The fourth term is 2 plus 7 is going to give us 9. And then the fifth and final term is the previous term plus 2. So it's going to be 9 plus 2 equals 11. And that's the answer to part A. Easy. When I look at part B for question number 15, I can see that it's geometric. We're going to be multiplying because 2 is right next to a sub n minus 1. And we also know that the first term is 3, so what is that going to be looking like as we proceed? Well, the value of the first one, as we just said, is 3. And what we're going to be doing is we're going to be taking the value of the previous term and popping it in. So the value of this equation is a sub 2 equals 2 times a sub 1. And what is the value of a sub 1? It's 3. So 2 times 3 is 6. The value of a sub 3 is 2 times the previous term. So 2 times 6 is going to be 12. And as we go through this, we can see that finally the value of the fifth term is the value of the fourth term times 2, giving us 48. So we're multiplying by 2 each time because we see that indicated right there. Let's take a look at part C. Here I'm noticing that in our template, it says a sub n equals n plus a sub n minus 1. Previously, we've had a number here when doing an arithmetic sequence, right? But now that n refers to the value or the number of the term. The value of the first term is 3, so we're going to rewrite that like a sub 1 equals 3. And now let's figure out what the second, third, fourth, and fifth term is. So what I know is that in this template, it says n plus the value of the previous term. So what is n here? N is going to be 2. So it's going to be 2, right, because n equals 2, and we see that's our formula. It's going to be 2 plus the previous value, which is 3, giving us 5. Here we've got 3 plus 5, giving us 8. Each time it's going to be the value of the term, so 4 plus 8 equals 12. And then the value of this fifth term is going to be n plus the previous term. So it's going to be 5 plus 12 gives us 17. Great. Let's take a look at this final recursive equation. Specifically, it's geometric. We can see that it's being multiplied. And it's a sub n equals n times the previous term. So the value, again, like all of the ones in this worksheet, the first term is going to be 3, so a sub 1 equals 3. But now, again, let's look at this template. So I see that the value that we're plugging in is what we see in the term. So this is going to be 2 times 3 equals what? 6. So now we're going to proceed like the way we were just a moment ago. So it's going to be 3 times the value of the previous term, which is 6, and that's going to give us 18. 4 times what? 18, and 4 times 18 is 72. And then finally, the fifth term times the value of the previous term, 72. 5 times 72 is 360. Beautiful. There's our answer for all these recursive equations. Number 16 says, find the missing terms in the arithmetic sequence. The first thing that I'm going to do is label each of these terms. So we've got a first, second, third, fourth, and fifth. And we remember that with this formula to find the common difference, which we know is either the addition or subtraction of a constant value, to go from one term to the next, a of f is going to be our final term. In this case, it's the fifth term with the value of 11. The initial, it's going to be 17 with a value of 2. So let's just simply pop those figures into this equation. So it's going to be 11 minus 17 divided by 5 minus 2. So 11 minus 17 is going to give us negative 6. 5 minus 2 is 3. This is the difference. Negative 6 divided by 3 can be simplified to, the difference is negative 2. So we're going to be subtracting by 2 by each term as we go through this. So when we're looking at it, if we're keeping in mind that the difference, of course, right, is negative 2. So 17 minus 2 is going to give us 15. 15 minus 2 is going to give us 13. Oh, that makes sense. That looks like a great pattern. But what about this number right here? We're going to be going the reverse, the opposite. So instead of subtracting, we're going to be adding 2. So the first term in this sequence is 19. And we just figured out what the missing terms are in this sequence.